Okay, we just did a bunch of multiplying polynomials, right? We said 2 to the 5th times 2 to the 3rd. We added those together and we got 2 to the 8th. Okay? Fine. Fair enough. What if I want to divide polynomials now? What if I want to take 2 to the 8th divided by 2 to the 3rd? How are we going to do that? Well, let's think about it. 2 to the 8th means I've got 8 of these creatures up here. And 2 to the 3rd means I have 3 of the creatures down here. And guess what? It's just like reducing a fraction. Cancel, 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 cancel. And how many are left? 1, 2, 3, 4. There's 5 of them left, so that becomes 2 to the power of 5. Okay, now, does anybody see how I could have more easily got that 5 than the way I got it? And of course, the answer is I'm going to subtract the exponents. Okay, so when I'm dividing, again, I need to have the same base, but I'm simply going to subtract the exponents instead of adding them the way I multiplied them. Okay, so generically presented here, b to the m over b to the n equals b to the m minus n. Okay, I have this extra requirement now that I'm thinking of it as a fraction, that b is not allowed to be 0, but I don't think anybody's tricking you with that one, because I can't divide by 0. Okay, so anyway, there we go. All right, let's do some examples. If we stick with 2 for a moment, 2 to the 8th divided by 2 to the 3rd. That's going to give me, that's the one I just did. 2 to the 5th. All right, there we go. X to the 13th divided by x to the 3rd. Subtract. I get x to the 10th. Y to the 15th divided by y. No exponent on that y. We know what that means. There's really a good old 1 there. And we get y to the 14th. Okay? So far, so good. What about x to the 6th divided by x to the 6th? If we were looking at, fractions, we might just say, well, those cancel. They're gone. Well, what happens when something cancels? What are we really doing? We're dividing something, right? Well, we're dividing something by itself, right? And if I take some number and divide it by itself, I never get 0. I get 1. So x to the 6th divided by x to the 6th is a 1, right? It cancels. It's something divided by itself. But let's look at our exponent rules, though. What do the rules say? The rules say I'm supposed to keep the same x, and I'm supposed to subtract those exponents. So 6 minus 6. So it's keeping that same x to the power of 0. And we're claiming that's a 1, and it is a 1. Okay? Anything to the power of 0, with the exception of 0 itself. We can't ever take 0 to the power of 0. That doesn't exist. But any other number, okay, maybe the x's make it look harder. Let's say 8 squared divided by 8 squared, okay? We cancel. We know they divide into a 1, but if I follow my rules, that should be 8 to the power of 0. Bust out your calculator and convince yourself. 8 exponent to the 0 power, you'll see you get a 1. Okay, so any number b, with the exception of 0 itself, to the power of 0 becomes a 1. Okay? Let's just practice that a minute. 7 to the 0 power, that's a 1. Doesn't matter if it's negative. That's a 1. Okay, however, be careful. If it's this, that negative out front is not part of the exponent process, so that's going to be a negative 1 there. Okay, so watch out for that one. I could have all kinds of clunky stuff in here. 10x cubed, all raised to the 0 power. I'm getting a 1 every time. Okay? The exponent of 0 kind of knocks everything down to just a value of 1. Alright? Alright. If I have the quotient of two things, I'm dividing two things, and they have an outer exponent, like I'm going to take some a divided by b and I'm going to raise that fraction to the power of n. Okay, well, everybody gets a raise. A to the n over b to the n. Okay, just that simple. So if I've got x over 4 and I want to square it, that's just x squared over 4 squared, which I would call x squared over 16. Okay? If I've got x squared over 5 and then I want to cube it, well, I'm going to multiply exponents here. It's going to become x to the 6th power divided by 5 cubed. Okay, and again, when we have the numbers, we can expand them all the way out and call that x to the 6th power over 125. Okay, something a little more complicated looking, some 2a cubed over b to the 4th, all of that raised to the power of 5, okay? Everybody gets raised to the power of 5. Notice there's no pluses or minuses in here. That changes everything, just like the FOIL process before. These are monomials being raised to a power here. 2 to the power of 5, a to the power of 15 over b to the power of 20. Okay, I could then further take 2 to the power of 5 and figure out what that is. 2 times 2 times 2 times 2 times 2, it's going to be a 32. A to the 15 over b to the 20. Okay, all good? All right. Well, let's divide some monomials now, shall we? Divide some good old monomials. So I've got a negative 12x to the 8th divided by a 4x squared. Okay, that's an 8 up here. Coefficients divide the way they always did. Don't forget how to divide negative 12 and positive 4. We've done it a million times. That's negative 3. We start subtracting the exponents only. Don't subtract the coefficients. Well, now I'm going to subtract and I'm going to get x to the 6th. Okay? 2x cubed over 8x cubed. Well, here's another time where you can just see the x cubes are going to cancel out. The 2 8ths, I'm going to have to leave it as a fraction, but I could reduce it and call it 1/4, right? But then I could call it x to the 0 here temporarily, but x to the 0 is just a 1, so it'll be 1/4. Okay? How about 15x to the 5th, y to the 4th, divided by 3x squared y. The 15 divided by 3 is 5. The x's divide here, so it's going to be x cubed. And the y's divide, it'll be a y cubed also. Okay? Dividing monomials. Okay, we good with that? Alright, we're going to just take it up one more notch and we're going to divide a polynomial by a monomial. Okay, so in other words, we're going to have a multiple part numerator, but still a single part denominator. My monomial is going to be in the denominator. That'll be the same, but a multiple part numerator. So in other words, negative 12x to the 8th, let's say, plus 4x to the 6th, minus 8x cubed, all of that divided by 4x squared. Okay? Now, let's, maybe we need to take a quick sidebar here and talk about fractions. Why not? Fractions rule. Let me just grab a piece of scrap here. When I asked you how to add 3/13 plus 5/13, what'd you call that? You called it 8/13, right? We had the common denominator, and you simply added those numerators together, right? Well, an intermediate step that we just never bothered showing was that we put the 3 and the 5 together over that common 13, right? We just, again, never bothered to write that step, but that's what we were doing. Okay, so that's what we have. We've got a multiple part numerator. over a single part denominator. So I can really bust that apart if I want to. I can bust this apart into 3 little separate problems. And I'm kind of cramming it because I'm running out of room. Okay, into that. Okay, now I had a reflex, wrote a plus there. I normally would have put a minus there and called that minus 8x cubed over 4x squared, but since I wrote the plus, I just put the negative up with the 8. But hopefully by now we know that those two things would be the same. I could have either put a minus there and left that a positive 8, or a plus there and made that a negative 8. But we got 3 little problems here. So think of them as 3 little problems, or I just like to work right here. Divide these two, divide these two, divide these two. So negative 12 divided by positive 4, that's negative 3. X to the 8th divided by x squared gives me x to the 6th. Here, 4 divided by 4 is 1, okay, and when there's a coefficient of 1, you're free to write it. You don't have to write it, but you're free to write it. X to the 6th divided by x to the squared is x to the 4th. And then here, a negative 8 divided by a positive 4 is a negative 2. X cubed divided by x squared just gives me x. Okay? All good there? One word of, caution, I guess it would be. Let's do one more. 10x to the 4th plus 6x cubed plus 2x divided by 2x. Okay? Let's divide this. 10 divided by 2 is going to be 5. X to the 4th divided by x is x cubed. Plus 6 divided by 2 is 3. X cubed divided by x is x squared. Don't forget this last part. Plus 2x divided by 2x is a 1. Okay, sometimes people forget about that little 1 there, and they're like, oh, somehow the problem's magically over before we get to that part because they cancel, whatever. I'm not sure what the thinking is, but you can't forget about that 1. Okay, it's part of the problem. Take 2x divided by 2x, and we're going to get a 1 there. Okay? All right, good deal. I'm digging it. All right, so we know how to divide these numbers, or so we think anyway, right? B to the 5th divided by b to the 3rd. What did we say that was again? We said there's 5 b's on the top, and there's 3 b's on the bottom. And then we did a little cancel, and we said there's 2 b's left, and we got a b squared out of the deal, right? Now we talked about how you subtract the 5 minus 3 to get it 2, right? All good. All right, what about this one? What about b cubed over b to the 5th? Well, I'm supposed to subtract the exponents, right? So that's b to the 3 minus 5. That's going to be b to the negative 2 power, isn't it? Huh. What do you know about that? Negative exponent. If I wrote it out, I've got 3 b's on the top, and I've got 5 b's on the bottom. And if I start cancel, I run out of b's on the top. And just like reducing a fraction, when you run out of stuff to cancel on the top, don't forget you always got a times 1 there. So there's still a 1 on the top. And I've got 2 b's downstairs, so a 1 over b squared. Alright, so we just worked the same problem 2 different ways, and we got b to the negative 2 one time, and we got 1 over b squared the other time. So we're making the claim that these two things are the same, and they are. Okay? A negative exponent does not make your number negative. It's all about position within the fraction. A negative exponent in the numerator of a fraction, I can stick a denominator there. A negative exponent up here in the numerator is equivalent to a positive exponent in the denominator. Okay, so sometimes we're going to get those negative exponents, and we want to get rid of them if that's the case. Okay? So, let's practice a little bit of that. Let's say I'm going to divide, let's say I'm going to divide, what do I want to do here? I don't know. Well, first let's make sure we have this down. If I say 7 to the power of negative 2, I say, show me that with a positive exponent. Think of it as a fraction over 1, and it becomes 1 over 7 squared. Okay, which of course is 1 over 49. Okay, if I say 4 to the negative third power, that's 1 over 4 to the positive third power. Okay, if I say x to the negative fourth power, that's 1 over x to the positive fourth power. Okay, so when I have a negative exponent, I'm going to move it to the other part of the fraction and make it a positive exponent. What if it's already downstairs with a negative exponent? In other words, what if it's 2 over x to the negative fifth power? Well, I'm just going to move it up to the other part of the fraction, and it will become 2 times x to the positive fifth power. Okay, it was in the denominator, now I moved it in the numerator. There's nothing left down there. You could show a 1 down there if you want. But I moved it because it had a negative exponent. Okay, what about this one? What about x to the negative third divided by y to the negative 4? Well, x has got to move down and y has got to move up, and then they have positive exponents. So it becomes y to the fourth over x to the third. Okay? I move it to the other part of the fraction, and the exponent becomes positive. Okay? Let's work a few problems like that. What if I took, all the rules are the same now. What if I took x to the negative ninth power times x to the fourth power? Okay? Rules are the same. When I multiply, I add these exponents together. Okay? So I'm going to add a negative 9 plus a 4, which I'm going to get a negative 5, right? X to the negative 5, and then I'll take the extra step to make that negative exponent disappear, so I'll call it 1 over x to the positive 5. Okay? What about a division problem? What about x to the fourth over x to the 20th? Well, now I'm supposed to subtract those exponents. 4 minus 20, so I'm going to get x to the negative 16, which is the same thing as 1 over x to the positive 16. How about 25x to the 6th power divided by 5x to the 8th power? Coefficients divide normally. 25 divided by 5, we've been doing it our whole lives. It's still a 5. Don't subtract the coefficients. Subtract the exponents. X to the negative 2 power, right? So I'm going to move only the negative exponent downstairs. The 5's not going anywhere. Just the x is going. Because it had a negative exponent, now it's got a positive exponent. Don't move stuff without a negative exponent. Okay? If I have something like this, if I have x to the 5th divided by x squared, and then I've got an outer negative exponent or even positive exponent, there's really 2 ways to do a problem like this. We can simplify what's in here first and then apply the outer exponent. That's the easiest way, so let's just do it that way. X to the 5th divided by x squared is x to the 3rd, right? But I've got this outer exponent of negative 3. They multiply, which gives me x to the negative 9, which is the same thing as 1 over x to the positive 9. Oops. Okay? Alright, I don't think you'll probably have too much on your exam regarding negative exponents, but that's a pretty good introduction. Typically speaking, we want to clear negative exponents out of there. Okay, if we see them, we clear them out by moving it to the other part of the fraction. But there is one area where it's okay to leave that negative exponent. Okay, and that's something called scientific notation. And we'll discuss that in the next video.